Hello friends, in this video we are going to see one-way slab and two-way slab design difference. Sometimes in the question they might not mention the slab type. In that case you must use given dimension to know the slab type. The formula for finding slab type is Ly by Lx. If Ly by Lx is greater than 2 means it is one-way slab. Lesser than 2 means it is two-way slab. So first we will find what type of slab the given question is. Next step, design constant. Why should we find design constant? Is the Q value is needed to calculate effective depth in upcoming steps, so we calculate design constant. For finding Q, first you must find M, N, J values to substitute in Q formula. First formula is M. M equal to 280 by 3 into sigma CBC. Sigma CBC is provided in IS 456 page number 81 table 21. And next formula N equal to M into sigma CBC by M into sigma CBC plus sigma ST. Sigma ST value is in IS 456 page number 82 table 22. Next formula J equal to 1 minus N by 3 and Q equal to 0.5 into sigma CBC into N into J. So this is used for calculating effective depth. Same goes to two-way slab. Design constants are same for one-way and two-way slab. Next, dimensions. For one-way slab, always assume width of the slab. If they didn't mention in the question, you must assume it as 1000 mm. Next, we must find depth provided. For the formula is span by 25. Next, effective span. There are two types of formula for effective span. First is clear span plus support width. Next, clear span plus effective depth. Whichever is lesser, we'll take it as effective span. Next, overall depth. Overall depth equal to depth provided plus clear cover 30. This is for one-way slab. Same goes for two-way slab, but depth provided formula changes. Span by 28. If you see in one-way slab, we use span by 25. For two-way slab, we use span by 28. Only slight difference for one-way and two-way slab dimensions. So next step is finding load. Load calculation is same in both types of slab. So always remember the slab unit is kilonewton per meter square and beam unit is always kilonewton per meter. First we must find self weight. Self weight equal to breadth into overall depth into RC. Live load. They might be given live load. If in chance they didn't mention about live load, you can take live load as 2 kilonewton per meter square. Next comes floor finish. Floor finish should be lesser than 1. So same goes for two-way slab also. Same for one-way slab and two-way slab load calculation. Next, bending moment and shear force. In this step, bending moment for one-way slab is WL square by 8. W value we calculated in load, so that is taken as W value. L is effective span. We must calculate with this data. V is shear force. Shear force formula is WL by 2. For two-way slab, bending moment and shear force. For two-way slab, we must find longer span and shorter span. For both span, we must find the bending moment. So the formula is in IS 456 page number 91. The formula is available there. Mx is equal to alpha x into w into Lx square. My equal to alpha y into w into Lx square. Alpha x and alpha y value is given in IS 456 page number 91 table 27. A small table will be given with the help of Ly by Lx data. Whatever you get the answer, you must refer the table and take the values of alpha y and alpha x. Next comes check for depth. For one-way slab, M equal to Q into B into depth required square. So we must find depth required. Depth required equal to root of M by Q into B. So finding Q value, we would have found the Q value in design constant. So that is being calculated in this formula. Okay. Depth required is smaller than depth provided. So this is the condition. It should satisfy this condition so that the design would be safe. And for two-way slab, check for depth is same as one-way slab. Next comes main reinforcement. For one-way slab, main reinforcement for one-way slab formula is M equal to AST into sigma ST into J into depth provided. So we'll find, using this formula, we will find AST answer. Then we must find small AST, pi d square by 4, that is the formula. So these two AST are found for finding spacing. Spacing formula is small AST by AST into 1000. After finding spacing, we will find number of bars. So formula for number of bars is effective span by spacing. Two-way slab main reinforcement formula varies. Means formula is same, but we must find for longer span and shorter span mx and my with the same formula, but mx value and my value differs. Mx is for shorter span, my is longer span. So the formula is m equal to ast into sigma st into j into depth provided. With this formula, we'll find ast. Next, small ast formula is pi d square by 4. This two formula is found for spacing equal to small ast by ast into 1000. So we must find spacing for longer and shorter span. Next comes distributory reinforcement for one-way slab. AST equal to 0.12% B into D. Small AST is equal to pi d square by 4. These two are substituted for finding spacing. Spacing equal to small AST by AST into 1000. Next, two-way slab distributory reinforcement. The formula is same for one-way and two-way reinforcement. That is distributory reinforcement. Next comes check for shear stress. It is same for one-way and two-way slab. So the condition for check for shear stress is tau v should be lesser than tau c. So the design will be safe. First, tau v formula is v by b into d. This formula is in IS 456 page number 83. K into tau c. K value is given in IS 456 page number 84. This value is referred with the help of overall depth data. Next, we must find the percentage to find the value of tau c. So the formula for finding percentage is 100 into AST into BD. With the help of this formula, we'll find the percentage, and percentage answer will be seen in IS 456 page number 84, table 23. Referring to this table, we'll find tau c value. So tau v is lesser than k tau c, means the design is safe. One-way and two-way slab check for shear stress is same. Next comes check for deflection. L by D basic equal to 25. Always L by D basic is 25, and L by D actual is you must find by calculating effective span by depth provided, whatever value you have got. Next, formula for L by D maximum is L by D basic into KT into KC. This KT and KC value is given in IS 456 page number 38 figure 4. Referring that, we will calculate L by D maximum answer. Next, if the condition satisfies L by D actual is lesser than L by D maximum, the design is safe. Check for deflection is same for one-way and two-way slab. So where the formula changes one-way and two-way slab is in main reinforcement the formula changes, and in bending moment formula changes. Then comes dimension, depth provided, span by 28. two-way slab, span by 25 for one-way slab. This is the difference between one-way and two-way slab. In next video, we'll see design of singly reinforced beam in working stress method. Thank you.